Hello everyone. Today we are going to discuss this particular question. This question is from this NPTEL course Introduction to Machine Learning. This is a question given in the first week of the assignment. Okay, so the question is regarding least square method. Okay, so here one data set is given and we need to fit linear regression model of the form y equal to beta naught plus beta 1 x1 plus beta 2 x2. Okay, so here x1 x2 two feature values are given, that's why this will be the for equation for the linear regression model, and we need to find out this particular equation by using the mean square error loss. Okay, so mean square error loss method, which is also known as least square method. Okay, so using this model we need to find out the y value for this particular given data point. Okay, so let's begin. So here this data set is given. Okay, so now what we need to do, we need to express this data set in matrix format. Okay, so in matrix format this entire data set will be represented in the form of y equal to beta then x plus epsilon. Okay, so here this y will represent all the values that is given in the data set, all the y values or the target feature values. Okay, then x will represent this x is a matrix only, it will represent the values x1 and x2. Okay, then here beta is will represent all the coefficient values. Okay, and then finally epsilon, this is nothing but the error value. So this error value will give us what? This error value will give us the actual value minus this beta x will give me a predicted value, right? So that difference will be that error value epsilon. Okay, now this data set, when I represent in this matrix format for linear regression, it will be like this. From here y, as I told, y will be the vector or the or this will be a 6 by 1 matrix or 6 by 1 vector because it is having 6 number of values. So 2.65 then minus 2.05 then 1.95 then 0.90 then 0.60 then 1.45. okay, this is my y equal to here I will be writing the x values. So x values, this particular linear regression model, it is having this beta naught. Okay, so this beta naught will represent the intercept values. So when I will be forming the matrix for this x1 and x2, okay, I will also be introducing the intercept value here. Okay, so 1 2 3 4 5 6 intercept value, the value will be 1, and then x1 value will be now this one 1 minus 1 then 2 then minus 2 then 1 again minus 1 and 0.5 then 1 minus 1.5 1 minus 1. okay, this is the matrix and what is the size of this matrix? 6 by 3. yes, then finally we'll be writing these beta values here. So the beta value, because it is this particular equation is having two variable, that's why how many beta values we are having? We are having 3 beta values, right? Beta naught, then beta 1, then beta 2. So what will be the size here? 3/1. Yes. And finally we can also have this epsilon value. So now we'll continue this particular computation here, but before that we'll see how we can find out what is our objective here. Our objective is to find the best fit values, okay, best fit values, this beta naught, beta 1 and beta 2. Okay, these beta naught, beta 1 and beta 2, these are the unknown values for us. Okay, x1, x2 I can obtain from the data set, the y value also I can obtain for the data set. But my problem is that if a new x1 x value is given, if a new x1 x2 value is given, what will be the predicted y value from the data set? Okay, so to find that out, we need to first find this particular equation, right? And in this equation, this beta naught, beta 1 and beta 2, these are the coefficient values, or you can consider as the parameters or the weight values which needs to be determined. We need to find suitable values of beta naught, beta 1 and beta 2, so that the y, this particular linear regression model, will best fit the given data in the data set. Okay, so how we can compute that? This beta matrix, actually ultimately we need to compute this beta matrix. For that, one normal equation is there. Okay, so the normal equation for this least square method, okay, least square method for the regression is it will be given as beta equal to x transpose x inverse multiplied by x transpose multiplied by y. Okay, so that means this x value, okay, this x matrix that just now we have got, this is the x matrix and this is the y matrix, right? So I can find out this beta value by using this particular formula. How we end up at this formula? Okay, that again this derivation of this formula, we have to see the theory of the least square method. Okay, there will be some data points and how I can fit the data. To fit that data at different, we need to find out the cost function. Okay, at different theta values, what will be the different theta value or different beta values, what will be the error or the cost, and where the minimum error will be. At that point we have to find out the slope. We have to take partial derivative or the slope of that particular function, and the slope, when it will be equal to 0, there minimum error is obtained. Okay, so from that particular mathematical equation, we end up at this particular formula. Okay, so we'll proceed with this calculation right now. For this particular question, whatever is given, the x values, x matrix is given, the y matrix is given, so that is that data is available with us, so I can proceed with calculation of this beta values. Okay, so for that, what we will do first, as you can see here, we need to calculate this part first. So let me again write the equation here. How I can find out beta? Beta equal to x transpose x then we will be taking inverse multiplied by x transpose y. Yes, so this part we need to find out, and for that what we will do first, let me divide the working space into two parts. So first here we'll calculate x transpose x. Okay, so from the previous slide, as you can see here, this is my x value, right? If I take the transpose of this, then all the columns will be in row format. So 1 2 3 4 5 6 ones will be there, and then next values are 1 minus 1, then 2 minus 2, then again 1 minus 1. Okay, then the next row will be 0 0.5, then 1 minus 1.5, then 1 and minus 1. So how we got that? This first row is the first column from this matrix because I have taken the transpose. Then the second column, okay, the second column will be the second row here, and the third column will be the third row here. Okay, so this is my x transpose multiplied by what will be the size here, 3 by 6 of this matrix, right? And then x will be same matrix only, but the original matrix 4 5 6, then it is what, 1 minus 1, 2 minus 2, again 1 minus 1, then 0.5, 1 minus 1.5, yes, then 1 and minus 1. Okay, and what will be the size of this matrix? It is 6 by 3. So these two are multiplication compatible, right? And the final matrix will be what? It will be of the size 3 by 3. So after doing this multiplication, okay, simple multiplication only we need to do, final value here is 6 0 0, then 0 10, then 5, then 0 5 and 5.5. okay, this is the final multiplication of these two x transpose multiplied by x matrix. Okay, then this is my so the next inverse part. So if I need to take x transpose x whole to the power inverse, then what is the formula for it? The formula for finding out the inverse is determinant of this particular x transpose x, whatever is the given matrix, multiplied by the adjacent value of that x transpose x. Okay, so this is how we find out the inverse. Okay, so after doing all the multiplication, what is the final value that I am writing here? The final value is 1 by 6, then 0 0, okay, this is 0, then this is 0 1 by 10, then it is minus 3 by 65, then 0 minus 3 by 65 and 10 by 65. So it is little lengthy, this calculation is lengthy, so final value only I am writing here. Okay, so the first part now we have with us. Now we need to go we need to calculate the second part, right? Second part is your x transpose y equal to, again x transpose, so it will be what, the same, this matrix 1 2 3 4 5 6, then 1 minus 1, 2 minus 2, 1 minus 1, then 0.5, 1 minus 1.5, 1 and minus 1. Okay, this 3 by 6 matrix multiplied by what? Multiplied by this y matrix. Okay, so y matrix already we have here. This particular matrix is the y matrix. it is a 6 by 1 matrix. Okay, so the same matrix we need to write here. So it is a 6 by 1 matrix, so I am not again rewriting the same because it's a long matrix. Final value will be what? Final value will be a 3 by 1 matrix, because this 2 will cancel out, right? So this final value is, directly I am writing down the final value after doing the matrix multiplication. It is 5.5. so it is then next value is 10.2 and next value is 5.725. okay, so I hope you can continue with this particular matrix multiplication. Okay, some just lengthy computation is here. So since I right now I have with me both the values, what I can directly do, I can directly calculate this beta values, right? Beta will be what? This first part, that was 1.60001 by 10, then minus 3 by 65, and 0 minus 3 by 65, and 10 by 65. okay, which was a 3 by 3 matrix, correct? Multiplied by this part only, I am writing here, multiplied by this one, okay, which is what? This 3 by 1 matrix, 5.5, 10.2, then 5.725. okay, so final matrix will be what? These two will cancel out, so final size of the matrix will be 3 by 1, right? So after doing this again matrix multiplication, the final value only I am writing here. Final value is 1.95, then 1.1 and 0.9. yes, so these are the beta values. These are what? This will be beta naught, this is beta 1, and this is beta 2, correct? So once I am having this beta values, you see here what was the equation? The equation is this one, right? Of this format. So final y value, predicted y value will be beta naught plus beta 1 x1 plus beta 2 x2, right? So just now we obtained the beta values. Beta values of 1.95, 1.1 and 0.9. yes, so first one is 1.95 plus what is it? 1.1 x1 plus 0.9 x2. is it correct? 1.1 is beta 1, 0.9 is beta 2, right? So now I need to if I have any pair of x1 and x2 values, I can find out the predicted y value, right? So we will go back to the question and we will see what it is asking. Using this model, that linear model, we need to find a predicted value of y at the point what? 0.5 minus 1. okay, so we got the values of x1, x2 here. This is the new test value, 0.5 and minus 1. so at that 0.5 comma minus 1, this is the unknown value or new test data sample for which I need to find out the y value. We'll simply substitute these two values, 1.95 plus 1.1, x1 value is what? 0.5 plus 0.9 multiplied by x2 value is what? minus 1. So after doing this computation, we end up with value what? 4.05. So this is the final predicted value, y predicted value for this particular pair of data points. okay, x1 and x2, that is given. So if we go and see the options, the first option only is 4.05, which is our answer, right? So this is how we calculate, we find out this particular predicted y value at some unknown test data point of x having the feature values x1 x2, here it is using this mean square error loss method, or which is also known as least square method. Okay, so I hope you understood the concept. So thank you.